Okay, guys, back on the second video for going over the homework for the review of polar graphs, chapter 9 review. And so we left off at question number 7. Let me go down here. So question number 7 is again another calculator problem. So R is the polar curve defined by R is equal to that function, 3/2 theta plus 2 cosine of the angle theta squared over 2. So where theta is going to go from 0 to pi. So when you look at this, you know your value has to be in there, okay? It's only defined from 0 to pi. So find the value of theta when the x-coordinate is -3. So what I would do with this kind of problem is I would say, recall that step 1, that x is equal to r cosine theta. X is equal to r cosine theta. Okay, so I want that to be -3. So I want to find out, well, what's going on here? Step 2, I would use the rectangular function. I would say, well, I would take x, well, actually, I would look at x is equal to, I'd put the r in. There's my function times cosine, just to get comfortable with it. And then what I would do, that x is a function of theta, I would change it to a function of x. So I know it's kind of weird. So it would be like a y as a function of x. And so then I would put that in the calculator. You can see what it looks like over here. And so y1 is f of x and y2 is -3, and I would find the point of intersection that occurs at 2.85989. I would round it to 2.8 theta. So what happens is that x is -3 when x has a value of -3 when theta is equal to 2.860. I challenge you to find out where it is on that particular graph, okay? All right, so the next one, we have a level 5 for a 5 for this graph. Now, if you look at the function, you have that there. And so it says the graph of the polar curve that's given is shown in the figure from 0 to pi. Which of the following statements are true about the graph of r at theta is equal to 5 pi over 6? So let me see, where do I want to go here first with this? The first thing I'm going to do is I'm going to take the derivative of the absolute value of r. These are all going to be positive r values then. It's going to turn them to positive values. When dr d theta, how fast is the rate of change of the radius with respect to theta at 5 pi over 6? I'm also going to look at how fast is x changing at 5 pi over 6, and how fast is y changing? I know you're looking at the answers there, but it says, which of the following statements is true at theta is equal to pi over 6? Well, the only way that I would get through this is to say, oh, okay, well, let me see. What's dr d theta? What's dx d theta? What's dy d theta? And again, it's the absolute value of that. So I get the positive and negative taken into consideration there. So the graph of r is getting closer to the origin, right? So I need to know about dr d theta, right? The graph of r is getting closer to the origin. Then the second one is the graph of r is getting closer to the x-axis. So if you look at what we're talking about with the first one, Roman numeral 1, is the distance from the origin. The second one we're talking about, you're getting closer to the y-axis. What's happening? You're getting closer to the x-axis. Oh, wait a minute, hold on. I have these written above, and they don't kind of correlate with what I have here. The graph of r is getting closer to the x-axis, so the x-axis is the last one here. And then the graph of r is getting closer to the y-axis, and that would be this. So the x, that has to do with the x value. I should probably change those around, but I think you guys can get it. So the last two should be switched in order, but they are saying the right thing. The distance from the x-axis is the absolute value of from the y-axis is the absolute value of x. The distance from the x-axis is the absolute value of y. I think the y goes up, the y goes down from the x-axis. So we find all three of those, okay? And it turns out, and this is again a calculator one. So we put that, we have the function value. We can put that in for r, and then, or we can put it in as an x function. And then dr d theta, we would just deal with that as we would normally deal with it with a function with math 8. And then the same thing is true with the dx d theta. So I get these three values, and the same thing with dy d theta. So it says that dr d theta is equal to 1/2 at 5 pi over 6. Dx d theta is equal to 0.7. Now again, that's positive. So think about this. The first one, r is moving away from the pole. So the distance is getting bigger. It's moving away. It's not moving towards the pole. And then the second one, dx theta, x is moving away from the y-axis as x is getting bigger, in other words, okay? The rate of change of x with respect to the angle, okay? So it's moving away from the y-axis. And then we have dy d theta is then negative, so y is moving towards the x-axis, okay? It's getting smaller, the y values are getting smaller. So in this case, the only one that's going to be true is B. Now, I can't remember if that was written wrong on your paper or not, but it's going to be, this is the only one that's true, is that Roman numeral number 2. The graph, x is moving away, oh, wait a minute, hold it, did I make an error there too? Hold it, it's positive, so it says, which of the following statements are true? So the only one that's not true, that's not true, sorry, I circled the wrong one. So it's not 2, it's going to be on this one, what's it going to be? So dy d theta, so it's moving closer to the x-axis. So I just want to make sure that we had that clarified. It's going to be this one, moving closer. So y is moving towards the x-axis. So that is the only answer here that is true. So that should be 2, that should not be 1. Okay, so we have that. And then the rest of them, I'm going to leave show here. This one is a little bit longer because you're taking the derivative. You want to find the slope, so you need dy dx. All that work is there. We went over that thoroughly in class. And then the free response practice, you are looking at this and you have several problems which are very engaging. The first one, you want to find the area. So I think you guys are good with this one. And you've got to split that little section S. Here's your S. You got to split that up into 2 regions. You see with the A then I find separately and just write it as A. You can do that on the free response section as well. And you can see the answers for this. Find R prime of 0. You're given R1, so you're finding dr d theta and evaluating it at a 4 pi over 11. And then what does this value indicate about the graph? Okay, so in this case, when you're at the point, you're getting the R value. Okay, the graph is getting closer to the origin. So you have that 4 pi over 11. I put into the R here. I got 2.34513. And then I got dr d theta at that same point, which is negative. That means the R is getting smaller, getting closer to the origin. And then from 0 to pi for this one, you're asking for when is R2 a maximum. So you take, for the y coordinate, find the value of theta for which the y coordinate is a maximum, justify your answer then, okay? So when you justify your answer, then you again are doing the closed interval method for the candidates test. You're looking at extreme value theorem on a closed interval, okay? There's got to be one. So we do that, we take the derivative. We have our function. We want to know where's the y value. And we can kind of see that you're using a calculator for this, see? So I would just take that into a calculator, and I would, y1 is the cosine, then y1 is the y value, or the y function r sine x, and then y2 is going to be the derivative of y1. And when we do that, then we get our critical numbers. So our critical number is going to be 1.898. And then with that, we're going to call that our C value. I don't know if I said that. Yes, I said that here, right here. And then I plug that in and I get an R value of 5.84492. And that would then, of course, at 0, the endpoints, here you have an endpoint here, and here you have an endpoint here. So they're both going to have an R value of 0. So you can see that the maximum must be at 1.89766, which would give a 5.84. Here, this one's pretty easy. So you're just looking at the position of the function. I'll let you take a look at that. That's probably fine. And then number 10, you're looking at this problem from a different perspective. I think you'll get this. You're given 4 choices here. None of them line up to dealing with 7 pi over 6 and 11 pi over 6 with that original problem. But I think you'll get that. And then same thing for this last one. Except remember, I give you the coordinates for the points. There's only one where the graph intersects at the same angle. At which value of theta did the 2 curves intersect? Only at 0.6998. And then you have one